Have you ever wondered how computer programs efficiently manage and organize large amounts of data? Today we're going to explore the world of heaps, a fundamental concept in computer science that's all about data organization. Imagine a pile of coins. Each coin has a specific value and position that defines its relationship with the others. Just like these coins, a heap is a data structure where each element has a value and a specific position relative to other elements. It's all about maintaining a certain order, whether it's from smallest to largest or vice versa. So, if you've ever been amazed by how smoothly your favorite software or applications run, heaps are likely working their magic behind the scenes. Just as you would sort and stack a pile of coins, heaps help us sort and organize data in computer science. Let's dive in and uncover more about this fascinating structure. Scene script. So what exactly is a heap in computer science? Picture a jumbled pile of coins, each with a different value. Now imagine you need to organize this pile in a way that each coin has a specific position relative to the others. That's the basic idea behind a heap, a data structure where each element has a value and a specific position in relation to other elements. And just as with our pile of coins, heaps are all about maintaining a particular order. This order can be from smallest to largest or vice versa, and it's what differentiates the two main types of heaps, min-heaps and max-heaps. Picture a pyramid of coins. In a min-heap, the smallest coin, maybe a penny, would sit at the very top. As you move down the pyramid, each coin is larger or equal to the one above it. This order ensures that the smallest element is always easily accessible at the top. On the other hand, a max-heap is like a pyramid where a gold doubloon, the most valuable coin, reigns at the top. Each coin below it is less or equally valuable. This way, the largest element is always at the peak. To sum up, whether you're dealing with a pile of pennies or a stash of doubloons, heaps help us keep order in the chaos. They transform a messy pile into a neatly organized structure. Whether it's a min-heap or a max-heap, the goal remains the same, maintaining order in our data. Now that we know what a heap is, what can we do with it? It's like having a well-organized library at our disposal, and just like in a library, we can perform certain operations to manage the data stored in a heap. First, let's consider insertion. Picture yourself strolling into a library with a new book. You don't just toss it onto any random shelf, right? You find its rightful place so that anyone can locate it easily later. The same goes for a heap. When we insert a new element, we place it at the end of the heap initially. Then we adjust its position based on its value, maintaining the heap's order. Next up is deletion. In our library analogy, imagine needing to remove a book permanently. You find the book, take it out, and rearrange if necessary. In a heap, especially a min or max heap, we usually remove the top element. After removal, we replace the top with the last element in the heap, and then adjust to restore the heap's order. Finally, we have an operation called heapifying. Think of it as a major library reorganization. In a heap, it's the process of transforming an unordered array into a valid heap. We start from the bottom and work our way up, rearranging elements until every parent-child relationship meets the heap property. From adding new data to deleting or sorting, heaps make these operations efficient and manageable. With heaps, we can keep our data as organized as a well-maintained library. Heaps are not just a theoretical concept, they have practical applications in our everyday life. Let's delve into some of these applications. In computer science, heaps are frequently used in priority queues, where tasks with higher priority need to be executed before those with lower priority. Imagine a hospital emergency room. Doctors don't see patients in the order they arrive, but based on the severity of their conditions. This is a prime example of a real-world priority queue, with heaps working behind the scenes. Heaps also play a crucial role in sorting algorithms, specifically in an algorithm aptly named heap sort. It's like sorting a deck of cards. You want to organize the cards from lowest to highest, or vice versa. Heap sort uses the structure of a heap to do this efficiently, making it one of the fastest sorting algorithms out there. And let's not forget about memory management in operating systems. Here, heaps help allocate and deallocate memory dynamically during the runtime of a program. Think of it as a resourceful librarian, efficiently assigning and reclaiming spaces for books as they come and go. Now, working with heaps isn't always a walk in the park. There are challenges one must be aware of. A common issue is heap corruption, which occurs when a program modifies heap memory it doesn't own. It's like a person randomly shuffling your carefully sorted deck of cards. The order is disrupted, causing chaos and potentially crashing the program. Memory leaks are another problem. They happen when memory that's no longer needed isn't properly released back to the heap. It's like a librarian forgetting to free up the space after a book is checked out. Over time, this can lead to decreased performance or even system crashes. To avoid these pitfalls, it's crucial to manage heap resources carefully. Always ensure to release memory when it's no longer needed, and be mindful not to modify memory that's outside of your own heap space. Remember, while heaps are powerful tools in data organization, they require careful management to avoid pitfalls. So there you have it, the secret to efficient data organization: heaps. We've journeyed through the basics, explored min and max heaps, and delved into heap operations. We've seen their real-world applications, from priority queues to sorting algorithms, and even addressed challenges like heap corruption and memory leaks. Heaps are indeed the unsung heroes of computer science, tirelessly working behind the scenes. Next time you're dealing with large amounts of data, remember the humble heap making your task easier. Until next time, keep exploring the fascinating world of computer science.